Okay, so let's get started. Thanks for joining that late. Today in my keynote, I have shown you my case study for Agentic UI, and it consisted of a dynamic dashboard you can display. You just describe it here, and then you get a dashboard like this one here. And it also consisted of this one, where you described what you need from the agent, and then you got a flight booking or flight proposals or your flight tickets. And now in this session, we have a bit more time to go into depth. That means we can look into the implementation and have a closer look at the concepts and at the protocols involved there. One important thing when it comes to this conversational interface here is that it is far more than just a chat. It is more than just a textual chat with a lot of information you get lost in. Usually it's a short conversation, a conversation that gets the user intent, a conversation that is producing something else in the working area, like here my check-in form that is already pre-filled for me. And it consists of several components that are interactive instead of just text I need to read. So let's have a look into this demonstration. In this example here, I'm starting with my sidebar, where I'm asking the chat several questions like, did I already book the flight for France? And then hopefully I get an answer in the form of an interactive component. No, something went wrong. What's going on here? Interesting. This seems to work. Did I already book France? Let's cross fingers. Yeah, here it is. Great. Great. And then I get my interactive component. I click here, and then I can fill out here this form, and some parts are already filled out for me. So another question, did I also book for Madrid? No, you did not book for Madrid. Search flights from Graz to Madrid. And now you see the agent is moving over to another route. It's pre-filling the search form. It's triggering the search for me, and I already see here my results. So now I could close the assistant because I'm faster when clicking at the flight I want to have. Or I could also say, please select the second one to get the second one selected. Yeah, nice. So at the end of the day, it's all about this short conversation, and then I can go on in the main working area. When we have a system like this, then we have an agent in the backend. This agent can access some tools. In my case, there was a tool that was loading my flights. And there are further tools for booking flights and canceling flights. And this agent here is also communicating with the LLM that might request this or that tool call. And in the front end, we have a counterpart that also knows about client-side tools that move over to another route, as we have seen, or that is filling up a search form or triggering a search inside of my component. And there are also a bunch of components that might be displayed in the chat. When we have a system like this, we usually quite quickly come up with some questions like, how does the client communicate with the agent in the backend, and how to prevent coupling to the server stack and the LLM in the backend. And the further question is how to support dynamic UI as an answer from the agent. And this is what I want to discuss here a bit more in depth. For this, I have prepared 4 things. I will get started with a quick introduction into Agentic UI. We talk about the AGUI protocol and how it works, which options we have in there. We talk a bit the A2UI protocol for constructing a dynamic dashboard. And we talk a bit about MCP apps for visualizing tools. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm helping a lot of companies with trainings, with workshops, and also with reviews. I'm also quite connected to the Angular community. I do a lot of stuff in Austria, but even more in Germany, and I'm always happy to work together with people around the globe. So let's get started with AGUI for the communication with the agent in the backend. As we have seen before, when we talk about agentic AI and UI, we have a situation like this, where there is some client that needs to access an agent in the backend. And this is usually done via HTTP and some kind of event streaming, perhaps server-side events or a WebSocket connection. When it comes to the communication here, we really need some kind of protocol. Because if we don't have a protocol, we very likely use what the backend stack is giving us. And this leads to coupling to the backend stack. And coupling is something we don't want to have, because it should not matter whether we have Spring AI in the backend or the Microsoft agent framework in the backend or the Google Agent Development Kit. It should not matter at all, and that's why we need this protocol for loosely coupling. When we have a protocol for loosely coupling to the backend, we are also loosely coupling to the LLM we have behind our backend stack. We need also a protocol for event streaming, and we need to be transport agnostic. Some people might prefer server-side events, others might want to go with WebSockets. A nice protocol for this is AGUI. It has been implemented and proposed by the people behind Copilot Kit. Perhaps you've looked into Copilot Kit. It's quite a common UI library, mainly in the React area for implementing conversational UI. And when we look to the SDK for AGUI, we see, well, it has been really adopted a lot and downloaded a lot. Meanwhile, we have about 700,000 downloads a week, which is not nothing. It's also well adopted by all the agentic frameworks in the backend, and we have support for all the mainstream languages there, Java, .NET, and so on and so forth. When it comes to AGUI, then AGUI is mainly defining messages for us. Messages to inform the client about what's going on in the backend. And this is necessary, because when we have an agentic workflow, this workflow will take some time. And so we need to inform the client on a regular basis what's going on there. Just to give you an impression about how this works, I have here 3 groups of messages. There are even more, but those 3 groups are groups of messages you most of the time are in contact with. The first group is about the run itself. An agent run is everything between the request to an agent and the answer you get back. Everything that happens in between, like an information from the agent that it is starting with the first step or the second step or the third step, or the information that we are now executing this or that tool. Another message group is just dealing with text messages, just getting back some textual information in a streamed way. And then it's all about tool calling. this tool has been executed on the server side to get more information about you and your current situation. That tool might have been executed on the client side to move over to another route, to pre-fill a form, and so on and so forth. When it comes to the run, then we have here a message for starting the run. This is not that exciting. It just says, okay, now we are starting, and this run has this ID. The ID is interesting because all the other messages will reference the ID so that you know that this or that message belongs to that very run. When we are finished, there is a finished event. This can be a bit more exciting, especially when the backend finishes with a question like, do you really approve this action? Or like, hey, here we have 3 options, please choose one. Then you know, okay, I can now choose from those options. I have now to present a Boolean, and then it goes on with the next run that will execute some further messages. And when there is an error, of course, there is a run error message. When it comes to text messages, each and every text message starts with a start event, and then you have one or several content events. One or several content events, and all the contents here are concatenated. That's mainly because we want to support textual streaming. So perhaps you are streaming word per word, or partial sentence per partial sentence, or sentence per sentence down to the client. And when we are done, there is an AND message. When it comes to tool calling, it's similar. We start the call for a tool, and then we can present arguments with one or many messages. Also, arguments can be streamed. When we have sent all arguments, then we send an AND event, and then the tool call starts, or the tool starts. So the word tool calling is taken really literally here. It's just about the call, and when the call has been executed, the real tool will be triggered. And once also the real tool is triggered, we get back the result of this tool. So let's have a look into this AGUI protocol and how it works in our very use case. For this, I'm switching back here to my assistant, and I'm also opening here my debugging console with the network tab. And over there in my assistant, one more time, I'm asking the question, did I book France? We have a tool calling, and here we have a first answer. Yes, you have booked to France. Here is your flight from Graz to Paris. So let's have a look into the streamed messages. And here I'm getting started with the headers. At first glance, it is just a post message that goes to this or that URL. When we look into the payload, we see several options there. For instance, we see so-called forwarded properties. In my case, the forwarded properties tells the backend about the model I want to use, which is more a wish than a command. It's more a wish because the backend can ignore this information. It depends a bit on your situation if you allow the user to choose the model. When it comes to an expert system like agentic development, then it might make sense to let us, the developers, choose between models for different tasks. In other situations, perhaps this is too much for the user. Perhaps they don't even know what to choose. Then here we have messages. In my case, there is only one message because the entire message history is stored in the backend. You know, the model is stateless, so the model always needs to see the entire chat history. But as I'm storing the chat history in the backend, I don't need to transfer it time and again from the client to the backend. That's why here we only have the last message. Did I book France? Something that is also interesting is here a collection of tools. tools I tell the agent about. Tools the LLM can select to be executed on the client side. And one of those tools is Find Flights. It's triggering a flight search in the client. Here we see a textual description. What does it do? And we see parameters. And when it comes to those parameters, this is already a JSON scheme, a well-defined way of describing the parameters we can send over. Here I have from and to, both is a string, and one more time for both there is a textual description. And this text is really vital here. Because of this text here, and because of the description of the entire tool, the LLM can choose for this tool. It can decide when and how to call this tool, when and with which parameters to call it. There is also a special tool in there called Show Components. And it contains a description of the components we can call. If I copy it out here to my window, then we see here also the shape of the tool call, and there are also some examples in there. So let me scroll to the side. Here, for instance, there is an example for a message widget that is just describing what message to display. A message with some text. Or there is another example for a flight widget. Let me look up the flight widget. Yeah, here we go. Which is describing which flights to display. A flight with this property ID, with from, with to, with a date, and so on. So what I'm doing here is I'm just giving the backend some examples of how to call this very tool Show Component. People call this few-shot prompting. I give a few examples so that the LLM can decide what to display when. Okay, so at the end of the day, I'm sending several pieces of information to my agent in the backend. First and foremost, of course, the question I have, but also some information about the client-side tools, and this also includes information about components to display. Funnily, what you have seen here is not really AGUI. It's perhaps de facto AGUI, but it's not part of the AGUI standard, because the AGUI standard is not describing this very message. The AGUI standard is describing everything that comes afterwards, all the messages that are sent to the client afterwards. Messages like, I started with this tool call, or messages like, hey, here I have some text for you. But this is at least de facto AGUI, because this is how the AGUI SDK is doing it. The standard does not describe it, but the official SDK needs to send this message somehow, and it is choosing for this way. So yeah, it's not fully AGUI, but a bit. When we talk about the AGUI protocol, this is what comes afterwards, our event stream. And here you see, well, we have run started. At the end, we have run finished. The run gets an ID, and then we have two tool calls. A first tool call for find booked flights. I want to know which flights the user has booked. And another tool call for displaying this or that component as an answer to the user. So this here is quite a nice view, but the real information is in here in the textual view. So this is for real developers, for us. So let's have a look into this first message, tool call start. It's just JSON. Here we have the name of the message, and here we have an ID for this tool call, and here we have the most important information, which tool to call. Find booked flights, it's a tool executed on the server side. Then we have several messages with arguments. or we can have several messages with arguments. In my case, there is only one message that tells me, well, here we don't have any arguments. We just want to have all the flights of the current user. Then we have another message that says, okay, I have now finished my tool call, and now let's start executing the tool. And after that, I'm getting back this tool call result, which says, okay, I have now finished the tool call with this ID, and here is the content. I have found this or that flights, a first flight with this ID, a second flight with that ID, and so on and so forth. So this is sent back to the model. And now the model has my original question. Did I already book France? And this first tool call result with all the flights I have booked, and now the model can come up with an answer. And this answer is sent using another tool call for the tool with the name show components. And there I will just show you the arguments, because I don't want to bore you with details. Here you see in the arguments, well, the LLM is requesting two components. The first one is my message widget with this text, yes, you have booked to France, blah, blah, blah. And the second one is our flight widget displaying a flight with this or that properties. I think this example shows two things quite nicely. The first thing is how AGUI works, and the second thing is how agentic AI in general works by a combination of tool calling, looping back to the agent, and getting a final result from the agent. However, this is not enough when we talk about agentic UI, because what we usually want to have is dynamic UI. Because here we talk about use cases that are that dynamic that we cannot foresee everything. And this is what was developed at Google. They came up with a protocol called A2UI. I know it's confusing. One protocol is called AGUI, and then another one is called A2UI. But both serve different use cases, and both work nicely together. This protocol A2UI, developed at Google, allows the LLM to construct a dynamic UI surface. And it works like this. You have an agent client that is sending a request to the agent, and this agent might send one or further requests to the LLM. And now the LLM is answering with some JSON that gives you a surface. This JSON could describe everything using A2UI, or it could just describe everything with a little tiny DSL. Sometimes the DSL is superior, because when it is about a DSL, the LLM can make less mistakes. It's easier for the LLM to grasp a simple limited DSL. If your LLM is strong enough, perhaps it can already come up with A2UI. But at the end of the day, what we are sending down to the client is really an A2UI surface. Perhaps we got it from the LLM, or perhaps we constructed it from this little tiny DSL. This A2UI payload has nice characteristics. First of all, as you see here, it consists of components. We have discussed this today in the keynote. One thing I did not stress out in the keynote today is that this entire component tree is flat. So usually you would expect children with grandchildren and grand-grandchildren. But here, Google decided that we want to go with a flat structure. And this serves several purposes. When it comes to flat structures, there is less opportunity for the LLM to screw up, to make a mistake. Because people found out that LLMs might have issues with deeply nested structures. Of course, strong LLMs are better with this, but even they may have sometimes issues with deeply nesting. This is one reason why we have a flat structure here, why we just reference other components on the first level with IDs like here. Another reason why Google chose for that was that with such a structure, it's easy to switch out just one component. So let's say I want to switch out my headline by just another representation. I just have to send down this one headline fragment with the headline ID, and that's it. Then my client can update its representation. And another reason why it's done that way, in a flat way, is JSON streaming. AGUI does not define how this here is streamed to the client. But one possibility is JSON-L, JSON line by line, you know. In each line we have another JSON document. And this allows, as mentioned before, streaming, so that the UI appears little by little. And also for this, a flat structure is a good idea. Another aspect that is really funny is that A2UI allows for data binding. You see it here in the last fragment. We are binding to a passenger that obviously has a name. And also this serves a purpose, namely when the passenger is updated, we just need to send down this data island with the passenger and nothing else. We have several renderers out there for different frameworks like React, Lit and Web Components, Angular and so on. And there is also a renderer planned for Android. This all has nice characteristics, like we don't need to execute foreign code. We have a clear separation between the structure of what to display and the rendering. How do we want it to display? And this assures that our fragment that is dynamically rendered does not feel alien in our application. This ensures that our fragment is using our design system, our design language, our colors, our fonts. One consequence of this is that the client needs to react upon events that happen in there in those dynamic UI fragments. That means the client needs to know about the name of those events. In A2UI, it's called actions, like in Redux, and it needs to somehow react when this or that action is triggered. Let's have a look into this. For this, let me switch over to another branch. Let me make sure that the backend still works. Sometimes it gets an issue when it gets a completely new branch on the fly, but all seems good. And now let's move to my dashboard. So this is a typical management use case, you know. You can describe here your dashboard with some lines of code, like, hey, give me my boarding pass for the next 2 upcoming flights. Give me a list of my booked flights, give me a dial to search for a flight, give me some options for renting a car, give me some options for booking a hotel, and give me the weather forecast. And this here is my dynamically created dashboard. If you look here, then perhaps you have recognized that those tickets look a bit better than the rest. And this is for a purpose, because everything else has been dynamically constructed by the LLM by just adding different options of the so-called basic catalog together. The A2UI basic catalog contains stuff like a title, like text, a button, or a text input, or even an image or a table. This here was constructed together. When it comes to my boarding pass, I'm using a predefined component. This is also a part of A2UI. A2UI can extend this basic catalog. It can tell the agent, hey, by the way, if you need it, I can also display this or that component. Here you have a description. It takes this or that parameters and displays this or that, which is the case here with the boarding pass. Yeah, we have here some images, a weather forecast, and we also have actions in there. For instance, I can say, hey, please check me in for this very flight here from Graz to Hamburg. And then I'm sent over to another use case where I can check in. Here I can also upload my passport to get everything pre-filled. Okay, now let's have a closer look to all of this. For this, I'm going back to my dashboard. I'm opening here the browser DevTools. And I'm requesting the dashboard again. And what you see here is that one more time, we have AGUI, which is here the backbone. And on top on AGUI, I am transporting my A2UI message. I really like this because this shows how those protocols come together. So if we look in there, there is a special message at the end called an activity snapshot. And this activity snapshot comes from AGUI. It's not the only possibility to transport A2UI, but it's a possibility out there in the examples of people that have created this standard. So it's more or less a de facto way of doing things, not an official way. And you see here the AGUI part, activity snapshot with a message ID, and then you already see operations defined with A2UI. The first one here says, hey, let's create a new surface. Some part in the UI we can paint on. And the LLM defined this ID here, surface travel 1. It also choose a catalog, which is here an extended basic catalog. And then it says, well, I want to update my components. I want to have a column with those children. Those children involves a boarding stack, a booked card, a search card, my cars, my hotels, and my weather card. So let's go down to cars, because everyone likes cars, right? So let's go down to cars. It consists of columns. Those columns consist of rows. And when it comes to those rows, we have 2 children in the first row, an image and text. So when it comes to the image, look here, we have a data binding to the first car, and it seems like it has an image property. When it comes to the column with the text, we also have further children, and one of them is pointing to the title of the car. And here we say, please display it with an headline of 3rd order. The text here is pointing to the price of the car. So if we go further down, we should also see the price somewhere. Here we go. This here is a message with the type update data model. And here we see, well, there was a data model updated under the above cars. And this here is our value, an array with my first car and the first price, the second car and the second price, and so on and so forth. And in there we also have our images. So far, we have seen 3 message types of AGUI, namely create an empty surface, update the surface with components, and update the data binding, update the data model we are binding to. And there is a 4th message, namely delete the surface. We don't have it here. And that's it. This is everything AGUI gives us. Now let's have a look a bit into the implementation here, into how my code is picking up everything. For this, I'm switching into my ticketing agent, into my ticketing chat service. And in there, we see there is a chat created, and this chat is just a resource. So here I really try to be idiomatic in the Angular world by providing a resource. An HGUI resource works like an HTTP resource in Angular or an RX resource. I'm defining the URL and the model I want to use. I'm defining that there is some memory in the backend so that I don't need to send the entire conversation time and again there. And then we have some tools. Tools we have already seen to be executed in the front end. And the interesting thing about tools is, as mentioned before, it's just about a description and a schema. Here a schema defined with SOT, with the schema language SOT, describing which data the tool can take. Here a search request for a flight going from this airport to that airport. My handler here is also typed with this SOT schema. TypeScript is great when it comes to inferring types. So just because of the schema here, TypeScript knows, yeah, we have from and we have to, and both are strings. And by the way, this is also the source for the JSON schema we have seen before, the JSON schema that was sent over. Besides this, when the resource is receiving an A2 UI surface, it's parsing it, and it's providing it to the UI. Also, it sets up some event handler that might be triggered by the generated A2 UI surface, like, hey, let me check in, or let me submit an answer for a question you had. In my case, I wanted to check in for this or that flight, so this very action was triggered. It's basically that. You need to wire up action names you have agreed upfront to some logic that will be executed when someone clicks at an action in there. It will be there in some seconds again. Okay, so besides receiving A2 UI and parsing it, we also need to display it. And this is what I'm doing here in my chat message HTML. In there, I have a loop for all the received messages. Messages are received via AGUI. And in there, when the message comes from an assistant, which is the backend, my agent in the backend, then I'm checking, do you have some string to display? Or do you have, besides the string, also widgets? And those widgets are already the past representation of the A2 UI surface. And if there are widgets, well, then I'm delegating this to this helper component that is using the SDK, the renderer of A2 UI, to display this or that A2 UI surface. So at the end of the day, it's about dealing with data structures, recognizing that I received A2 UI, and when I received it, then I display it with this or that helper component. Okay, so last but not least, let's talk a bit about MCP apps. As mentioned in the keynote today, it's all about calling tools, but now it's not about my own tools, but about tools from other systems. For this, MCP is describing an interface, but also it is describing how to call this interface. And this can be done using standard in and standard out if you only use local tools. This is usually done in a setup where you have everything locally, like, like agentic development, where you want to hook up your unit tests into your agentic workflow, or the results of end-to-end tests, or the results of some tool that is evaluating your source code against best practices. When it comes to business scenarios, most likely you will go via HTTP and or server-side events. So this is what MCP gives you, and it's really well supported in all the languages. And there was recently really a hype. Here we see that currently we have 34,000 downloads a week when it comes to the SDK for TypeScript. This is only the SDK for TypeScript. There are further SDKs for Python and so on. MCP apps adds a layer on top that allows you to visualize your tool results. For this, it provides code for you, code that can be written with each and every framework. And as this is foreign code, it's executed in a sandbox, in an iframe, because you never know what you get from there. It's like, you know, Forrest Gump, a box of chocolate, you never know what you will get. Perhaps it does something harmful. You need to prevent this by sandboxing it in an iframe. It allows you to establish a context. You can tell this component inside of the sandbox which theming you are using, dark theme, light theme, what are your colors, what are your fonts. And you can tell it how much size it has in there in the iframe. Besides this, you can define messages that go into it and also events that come out from it. This is mainly defined by the MCP apps protocol. And now let's have a demonstration for this. Let me check out my branch with the MCP server. MCP apps. Okay. I've written something into the source code while talking. Sometimes I do this. MCP apps. Let me start my MCP server. Let me assure myself that the backend is running. No, as mentioned before, sometimes this happens when I quickly switch out the branch underneath the covers. It's like switching out the motorcycle while driving with it. And now, when I go to booking, I want to ask, I need a hotel in London. And here you go. This is my iframe. And when you do it nicely, you don't even recognize that this is an iframe. So it's not that bad as some people think. It's also not that great, especially when it comes to SEO. But it might be okay-ish in an enterprise application. And I can refresh my view to get further hotels. So one more time, the interesting thing here is the protocol level. So let's have a look into our network tab. And let's trigger this search one more time. Give me hotels in Paris. Yeah, looks good. And now let's have a look here into this. So what we have here one more time is HUI. This is our backbone. And here we have some tool calls, and we are lucky because my client, or to be more precise, my agent found out that my request can be served with the MCP server over there. For this, we just have 2 lines of code in the source code, mainly with the address of the MCP server. Everything else is done via the protocol. And then we have some HUI messages there, and there is my activity snapshot. Let's copy it into my IDE. Let's save it. Let's format it. And one more time, we have this HUI header with the snapshot. We have a certain activity type, MCP apps, so that the consumer knows, okay, now I'm getting something that aligns with the MCP apps protocol. The contents themselves is already what the protocol tells us. It tells us that we have now executed a tool from this server. Each and every MCP server has an internal ID. And here we have a URN, a unique resource name, that points to some snippet, to some code snippet in the space of this MCP server. So it tells me, please display this snippet in the iframe. So because I know the MCP server and because I know this logical URL, I can tinker the real URL and load this fragment from over there. Besides this, what I'm getting here is the tool input. This was the parameter we sent to the tool. I searched for hotels in Paris. And here we are getting back the content. Here it is textual content. And here it's already the textual content in a parsed way, namely just JSON with the tool results. Hey, this was for the city of Paris. Here are your results, this and that hotel with this and that properties. This is sent into the iframe, and so the iframe knows what to display. When we click this button, an event comes out of the iframe, and so we know we need to trigger the backend once again. The nice thing about this implementation, and this is the last thing I will show you, is that as I have abstracted all those protocols in my convenience layer, the chat message HTML does not need to know about any difference. It is still displaying these widgets. It is still iterating over all the widgets we got from the backend. And here, this widget container now knows that if this widget is associated with MCP apps, what to do. So it's really nicely abstracted. I don't need to change this part of the code here. If you like those topics and if you want to go more into depth, more into the protocol level, but also into the implementation level, you might also like my current book. This is my current project. I will finish it during summer. So now you know what I will do during the summer holidays. And there is a waiting list. If you want, you can subscribe for this waiting list at agentic-angular.com. Okay, let me conclude. What did we see today? Well, we have seen that AGUI acts as the backbone of all of this. It is decoupling our client from the server stack. That's really important because we don't want to be dependent on it. It should not matter whether we are using Spring AI or the Microsoft Agent Framework, Mastra, LangGraph, LangChain, or something else. We have seen that with AGUI, we are transferring events, and so the client can also select components. Components to display, components the LLM has chosen for. We have seen that A2UI goes one step further. Instead of just telling the client which component to display, A2UI can dynamically create a surface, a UI surface to be displayed in the front end. For this, it can stick together existing components, but also additional components I provide. And we have seen that MCP apps is all about visualizing tool results. One layer on top of MCP, not just about getting results, it's also about visualizing them. And that's it. So thanks for joining today. Here you find my contact data. Feel free to follow me on social media like LinkedIn, Twitter, Facebook. And you also find here on my blog my slides and my entire source code examples for the case you want to play a bit around with it. So thanks for joining today. Have a nice conference.